In this video, I'm going to show you how to plot analysis of variance results using ggplot, and I'm going to show you bar charts and box plots. By way of confession, these things take time to do in order to make them look the way you want, but I'm going to try to make it as quick and easy as I can for you. Okay, so what we want to do is I'm going to explain to you a study that I was involved in and show you the R code. And import data from that study into Excel, and then I'm going to calculate what I need for the bar chart. I'm going to create a graph using a bar chart, ggplot. I'm going to do it in black and white and then color. Then I'm going to graph the same thing using box plots, and then I'm going to compare the two side by side, and I'm going to try to convince you to use box plots instead of bar charts to do these kinds of graphs. Okay, here I have Chrome at Google, Michael Panic GitHub regression. Sounds good. All right, well, go here. Meta-analysis regression. Okay, so I want two of the files here. I want this one, ANOVA plots R, and then I want surge.xlsx. So I'm going to click on this, and it gives me these choices, and I'm going to choose raw here. And now I'm going to just select everything in the file, right click, copy. And now I'm going to open up R Studio, and I'm going to File, New File, R Script, right click, paste. Alright, so now I've got ggplot for ANOVA results, bar chart, and box plots. Okay, so this is the program that I'm going to want, but now I need to go back here to GitHub, and I need this other file. So surge.dat, I click on that, and now I have a choice to download it here. So I'm going to download, and it says it's downloaded. So I click on that, and here's the file. I'm going to say File, Save As. I want it as surge.dat. I don't need a one dat. And I want to put it on my desktop. All right, so I got surge.dat, saved it. Okay, so now I'm going to get rid of GitHub. So I've got my program and I've got my data. And the things that I want to do first are to sort of describe for you what's going on here. So we're going to ggplot for ANOVA results. We're going to have bar chart. We're going to have box plots. This is the stuff that I put in the front of most of my programs to clean everything out of the console. We'll run that. The things that we're going to need for our plots today are psych and ggplot. Those are the two libraries. So psych is for descriptive stats and ggplot is for the plots. All right, those ran. So this is a study of surgical training. So the data dependent variable is surgical performance measured as steps in a checklist. So they have faculty watching young surgeons try and do the surgery. Each time they do something right, they get a check mark, and they count up the number of correct steps. The training was randomized into two groups. We have a live tissue training where they worked on an animal to learn the surgery, and then there's a simulation training where they worked on a machine that doesn't actually bleed or anything. It's a simulation. Both groups were tested on their psychomotor performance, that is the steps in the checklist, before and after training. So the design is analysis of variance. It's a split plot or a mixed design. There's one between, which is kind of training, and there's one within, which is trial, before and after. So there are about 45 people in each of the training types. So we have about 90, 180 observations about. I took the data and I added some random error to their performance scores so that the data are not the actual data of the scores of the participants of the study, but the patterns are going to be the same. So you can't tell who's who or anything about the people. So it's all, essentially it's simulated data. But it's really close to to the real thing. Okay, so first thing I got to do is I've got to import the data. So I'm going to go over here, import data set from Excel. I want to browse. I'm going to go to my desktop, and I need surgical data. So there it is. Open. And here it is. And I import. And now I've got, these folks were trained a live tissue. This is time 1, and here's their performance scores. And these guys were trained using simulation. This is time 1 performance scores. And you got live tissue post-test, and you got simulation post-test. So these are the data. Let's go back here. Okay, we imported the data. Let's see what it says about the data. It says we've got a table, and we've got 2 character values. We've got the training type and the time pre and post, and then performance is numerical. And I can print it out again if I want to, and you can see the first 10 cases. So that is a tibble. We've got training, live tissue versus simulation. We've got the time pre and post, and we got performance scores. Okay, now first thing I want to do is create a conventional bar chart, which is the way that these things are typically presented. And in order to do that, I'm first going to create a subset of the data for each of the 4 cells. So I've got live tissue pre, live tissue post, simulation pre, simulation post. These are my 4 cells, and I want to subset the data for each of those things. All right, so when I do that, I've created now 4 partitions of the data. And now the describe function gives me descriptive statistics for whatever I put in there. So I'm going to call, I got an object A, it's going to describe cell 1 performance. All right, so I've got performance data described by each of the 4 cells, so A, B, C, D. A, it says this is a performance data for cell A. I've got 47 observations. The mean is 8.02. Standard deviation is 6.31, and so forth. Okay, so the cool thing about R is that the A is a list, and so it has a stuff in it, or maybe it's a data set. It doesn't matter. When I say $, mean, it gives me the mean. So it's 8.02 here. All right. So now I'm going to collect the data in such a way that it's handy to plot. So I've called it plot.dat, and it's a data frame, and it's got training and time and means and standard errors. And here I've got live tissue pre and post. Notice this is the A cell mean, the B cell mean, the C cell mean, the D cell mean. This is not a battery, and the standard errors. Okay, so that came out of the standard error here. I run that. It says I've got plot.dat. Now let's look at what it is. It says we've got the 4 cells here, and we've got the mean and the standard error for each of these. All right, so now I'm ready to do the bar chart, and I'm calling it motor bar for motor performance, or psychomotor performance, a bar chart, and that's ggplot. And now the data is plot.dat, so it's that data. The aesthetics x, my x variable is training, so that's simulation or live tissue. Y is the mean performance. Fill is time, so these are going to get a different bar for pre and post. Okay, so then that's the main structure of it, but now we actually have to give some plot things in here. So I've got the motor bar plus I want bar, so geom bar. Stat is identity, position dodge. So that's going to take my position for the fill plus error bar. So I want an error bar because that's I want to go up above and down below the mean to show people where the likely places for the error bar are. The aesthetics for that, so the minimum, I want the mean minus 2 times the standard error, and the maximum to be the mean plus 2 times the standard error. This is the width of that error bar line, and the position is going to be the position for these guys. Okay, I'm going to label X training group, I'm going to label Y steps correctly completed, and I'm going to, let's see, paired. Okay, so this is going to give me colors from the Brewer palette. So let's see, let's try running this thing. Run. And here you see the result. Here's the live tissue group. Here's the simulation group. You can see that there's a big difference pre to post. The error bars for pre are pretty much overlapping as they are for post, and pre and post don't overlap. So we've got the steps correctly completed, and you can see it's about 7 versus about 6 and about 17, 18, something like that for the simulation and live tissue groups. All right, so this is the kind of thing that you would save and then plug into a presentation because this has nice colors. But for publication, you don't want colors, you want black and white. Here I've done the same thing except for the scale values are dark gray and light gray. So I'm going to go run this. I didn't ask it to print, so let's ask it to print. All right, and now you see that it has printed it, and now you've got the light and dark gray, and this is the kind of thing that you need for publication. Unfortunately, when you go to save this and blow it up a little bit to put it in your publication, well, this print is too small. So what I did there was I changed the elements for the titles and for the legend and for the titles, and then I want to change these labels as well, and that's where I've got the elements changed here. So let's run that, and when I do, I've gotten much bigger. Notice that here they're overlapping because, well, this is too small a window. But now they're much larger, and when I put them in my file for my publication, or I upload them to the publisher's website, their online, submission portal, then they'll be big enough so that you'll be able to see them, and this is the kind of thing that you want. Now, what I do is I save through the export. So I saved export, save as image. I want to put this in the directory. I want it on my desktop. I want to call it bar chart, and I want it to be bigger. So I'm going to say 500 by 600. No. 600. All right. Save. All right, and here it is. And now this I can put into a Word file. So in Word, it would be something like this. I've got that, and then I've got Figure 1 surgical performance steps correctly completed as a function of type of training, live tissue versus simulation, both before and after training. And so this is the title of Figure 1, and then I've got error bars, or group means plus or minus 2 standard errors. And the standard error was computed separately for each cell. Okay, so that's the sort of the explanation of what's going on in this. All right, so that's the way I would do this for an APA publication. Okay, so there we have the bar chart. Now we'll do the same thing for the box plot. So let's recall our data. Surge det. Okay, so it's a Tibble, and it's got the kind of training and the time pre-post, and it's got the performance in it. Now here, I'm going to say motor box instead of motor bar. Motor box gets ggplot. Data is equal surge dat. So that's, notice that we're now using the raw data instead of the calculated data. Aesthetics X is training, Y is performance, fill is time. So this is the same as it was last time, except for the name of the data set has changed. All right, motorbox plus geom. I want a box plot now. I'm asking for notches. I'm asking for the position to be the position of the dodge, so this like this kind of thing. Plus stat summary, Y is fun. I want the mean in addition to the median in the box plot. So the box plot produces the median, but I'm asking it to give me mean, and I want it to create it as a point, and I want a shape of a diamond and size 2, and the position I want it dodged along with the box plot. Here I've got training group, steps correctly completed, just like I do here. And I've got the dark gray and light gray. All right, so let's see what happens when I run that. All right, and here we have the box plots. And you can see this is the live tissue folks, and this is the simulation folks. And the notches are indications for the confidence interval for the median here. And here we've got the mean and the median co-located. Here the mean is below the median. There's some outliers here. What's really interesting is that these are the live tissue people, and there are 2 of them that apparently didn't really learn anything through the training. Okay, this poor person is just not able to do the surgery. And here we've got the simulation group, and you notice one of the simulation people was already proficient in doing this before they were trained. So they had some kind of previous training before they got here, clearly. Okay, so this, I like this because it gives you a lot of information about the distribution. It's not just giving you the means, it's giving you the means, the medians, and information about the distribution, including the tails and outliers. Okay, so so this I would use for my publication. You can also color these for a presentation, just like you could for the bar chart. Okay, I'm going to run that, and run these. Now my school is University of South Florida, and our colors are green and gold. So if I were doing a presentation, I might want to use the school colors, and I actually Googled the school colors, and you can find the hex codes for them, and I plugged them in here, and you can see this is our green and this is our gold. So you can you can use those for your charts, and put your school's logo in the chart and do all that kind of stuff when you're doing a presentation. Obviously, for a publication, you wouldn't do that. So if you did it like this with the box plots, then you'd also have the figure caption and description. And I wanted to show you, they're lined up side by side here. And notice here you've got the top here is 20, and here's 20 over here. And you can see that the means are represented just the same in the 2 different graphs, but you get a lot more information using the box plots than you do using the bar charts. So the bar chart is based on the notion that the mean is the only thing that's important. And in analysis of variance, it's customary to assume that the variance is the same in all the cells, so that's the homogeneity of variance, and the data are normally distributed. So if that's the case, then the mean carries all the information that you need to know. And if you compute these error bars using the standard error for the analysis of variance, then the width will be the same for each cell because the homogeneity of variance assumption is such that they are the same. Well, you can cover up a whole host of sins doing that. Okay, so this lets you see, oh, we got some problems here. We got this guy here, you know, and particularly if you are presenting this to a decision maker, someone in industry or in the hospital or whatever, they should know that there are a couple of people who didn't learn anything apparently in the training here, and we need to go find these people. I don't want them operating on folks. And this guy should probably be gone. I mean, we should be screening people out if we really want to do this in a fair way. So anyhow, you get a lot more information. This here's that 20 here. We go all the way up to I don't know where. I guess I need to do a better job here. So the other thing is, notice how in the first chart I've done things to make the numbers bigger. So this chart isn't ready for publication yet. I've got to fix the numbers, and I probably want to put a 30 up here, which I can do with a little work. And that's the end of this video.